Hello everyone. We are in the Internet and Web Programming section, and today we will discuss about addressing and routing section. Addressing. Addressing means to give someone an address. Addressing are basically two types: local address and global address. The local communication address means link the like as the link layer, that means which is the MAC address. That means you have two devices in your hand. Your each of devices have a separated MAC address, which is media access control address. That MAC address is separated from each and every device in the world, and that is why it is the basic function of local communication address. And if you want to communicate with the internet, you need to have an IP address, which is known as the global address, which is the internet protocol address. The private and public section. You want to have a public or private IP. This is known as a public and private section. Now, temporary precedence. That means you get an IP address or a Ethernet network card which can generate temporary addresses for temporary of precedence. IP address is based on the TCP IP protocol, which is on the transmission control and internet protocol. This IP address can be easily changed from each device to another device. Each devices which is connect with the internet right now have different IP addresses on their internet. This IP address is divided into two sections: IPv4 and IPv6. Here we can generate subnets by first we need to take the IP address, then the mask. We will discuss about how to generate the mask and the IP address. After make the XOR function, we can generate the subnet. That is how we can generate the subnet of this IP address. IPv4. IPv4 means the IP Internet Protocol version 4, which is the 32-bit address. Now, address space. If a protocol use b bit to define an address, the address space is 2 to the power b because it is having two different values, 0 and 1. That is why IPv uses 32-bit address, which means that the address space is 2 to the power 33, which is a billion value. If there is no restriction, more than 4 billion devices can be connected to the internet. That is known as the address space. Now the notation. As you know, this IPv4 have 32 bits. That means it have 8 bit, 8 bit, 8 bit and 8 bit section. That is total 32 bit. This 8 bit generates a section before the dot. In between this dot, this is another section, this is another, and this is another. That means it has 4 decimal section and 4 hexadecimal section. Now, subnetting. Subnetting means to breaking the large network into small networks, because if you don't subnet your networks, your IP will be misused. That means you are getting the IP 1.0.0.1. You are reserving a serial of 1.0. It tends to from 0 to 100. You are using only one device, but you are reserving from 0 to 100 device, which is not very efficient. That is the reason we need the subnetting. The advantages of subnetting is given here. To create small networks for easier access, it reduces the network traffics. By subnetting mask, we have three classes: class A, class B, and class C. In this section, we have the subnet mask. For the class A, it is 255 and another 3 are 0. That means 255 is for consecutive ones, which is for the network section, and for the host section there are 3 zeros. And in this section we have two network sections. That means 2 255 and 2 zeros means two host sections. And lastly, in C section we have one host section and 3 network section. That means 2 continuous 255. Subnetting for class B networks. By this diagram we can easily see that here we have class B. That means we have 255 and 255 for network and 00 for host. Here we have one network and need to connect with 64K devices. In this first section we have 255, then 192, and then 0. In this section we have the 2-bit mask. In 2-bit mask we can easily communicate with 3 subnetting, and under this subnet we have those type of devices. After that we can divide it by 3-bit mask, and in this section we can have 7 subnets and we have that much devices. And moving on, finally we can have that in 8-bit mask we have 255 subnets and each subnet contains 254 devices. That means the much you subnet your network, the much devices you can get connect. Here are the difference between subnetting and supernetting, which is very important for exam question point of view. Subnetting is basically means to divide the network into small networks, and supernetting means we combine the small networks into a large networks. The supernetting is also important as the subnetting. The subnetting mask is applicable for a single network, but supernetting mask is applied for 2 or more networks. Those networks should be in the same IP address. Have a snap of this differentiation. By this mathematical notation we can easily solve by that a company has bought an IP address which is 136.178.0.0. It has 14 departments and it wants to give each of a own subnet. That means we need to divide them into 40 subnets. For that we can see we are in the B class address because 136 is in the P class. That's the reason we need to have 14 subnets because we have 14 departments. That means we required 2 to the power 4, which is 16 subnet divides. That's the reason. So we play with the first 4 bit with the third octets. That mask will be 255, 255 and 240. We started from 136, 178, 00. We started, and this is the number 1 section, and the last section is 136, 178, 240, then 0, which is the last section. We remove the first section and the last section. Now we can get the 14 subnets, and you can see that each of the subnets is different from each other by 16. How it will happen? Because we have already seen that we have to divide them by 2 to the power 4, that means 16 subnet devices. Each of this section for this reason each of this section is divided and differentiated from each other as the value, which is 16, 0, 16, 32, 48, etc., and moving on. Then the subnet mask. In this section of classification, we can see that if the value of the first octet is from 0 to 127, it is in the class A. If it is in this range, it will go to the class B. For class C, this range. For class D, this range, and class E, this one. For this class A section, we have host 3 to the power 8, that means 24 bits, and the host number is 2 to the power 24 minus 2. Here the network number is 2 to the power 7 because the first bit is reserved. In class B section, we have host 2 to the power 8, and for host number we have 2 to the power 16 minus 2, and in network section we have 2 to the power 14 because first 2 bits are reserved here, and in C first 3 bits are reserved in the network section, and so the network number is 2 to the power 21, and here the host number is 2 to the power 8 minus 2, and in host section it have one octet, that means 1 to the power 8, which is 8, not 24. This table is very important for your exam point of view. Have a snap of this one. This divides the IP into class A, class B, and class C. Now, the classless inter-domain routing, which is known as CIDR. In this section, class A, which is defined as subnet, which is 255, and another sections are 0. That means the first octet of subnet mask has all the on bits, which is 1, and in slash notation would be written as 8, means the address has 8 bit on. In this class B, if we generate CIDR, then we can write 16 in this last, and this denotes that the address is 16 bit on. In this class C, we have 24, that means 24 bits are on in classless interdomain routing section. Now we are in the variable length subnetting. In this variable length subnetting, we don't need to subnet them properly, because subnetting is to divide the network into number of equal size subnet, but in variable size it is not mandatory. Variable length subnetting is to subnetting for non-equal or variable length subnetting. In this section you can see that here we have our class B IP address, which is 137.178.0 and 0. Then we have divided into sections like as marketing, engineering, administration, sales, R&D, and supports. Total we have 43 groups, and the size of group is 5730. Now we need to solution them. In this section we have class full solution gives us 65534 devices, but that's enough device to put all the departments in 5730 devices. So if we take this class full solution, then the maximum device will be unused, and for this only simple amount, which is 5730, this all IP address will become wastage. So we need the variable length subnetting. In this section, first we have Let's have a subnet per group. Then we have 43 groups. So we need 2 to the power 6 minus 1, that means 63 subnets, by which means we can use 6 bit for each subnet part and remaining 10 bits are for the host. By this section we can easily say that 10 bit for host means it gives us 2 to the power 10 minus 2, that means 1022 devices, and marketing section have 1095 950 devices, which is not enough, so we need to divided them variable sections. First, 4-bit mask. In this section we need to start with the 255, 255 and 240, and 0 gives us the 15 subnet of each device, that gives us 4096 devices. That is enough for engineering and marketing. That is why engineering section have 3 subnets, which are 16, 32 and 48. In marketing section we give right after the 48, which is the 64 number. In administration section we give them the number 80. Now in this 8-bit section we need 255, 255 and 0, which gives us the 255 subnets and 255 devices. That is fine for sales and R&D supports. In here, from this remaining 10 subnets we break them into sub-subnets. That means those are subnets of subnets. For example, the last subnet was 80, so the next subnet will be 96. Then we will break it into 15 subnets, which will start from 97 to 111. That is how we break them into 15 different subnets, which are the subnets, because those are already subnetted by 96, and in this section we generated again as a subnet which is from 97 to 111, that is why we generate another 15 subnets. That's the reason we call it as subnet. We still need 23 subnets and 1 for R&D and 22 for supports. For this reason we break the next to the 112, which one is the right after 111, and then the next subnet is 128. Now routing. Routing means the work of path. This routing generates the path signal. How the data will send from one place to another, what will be the path, this is the work of routing. Here routing have two types, static routing and dynamic routing. In static routing it is used in the small network, but dynamic routing is used in the large network. In static routing no such algorithm is involved, but in dynamic routing algorithm is involved. Static routing is more secured, but dynamic routing is less secured. The difference between static and dynamic routing is given here. You can have a snap of this one. That's for today. Thank you.